Hello everyone, welcome to the Networking Basics mini lecture series. In this mini lecture we will address the topic of IPv4 basic subnetting. Subnetting, what is it, why, how, and a couple of examples, and finally a practical case study. Subnetting allows the creation of multiple networks from a single address block. Why do we subnet? To maximize the addressing efficiency, to extend the life of IPv4. And how, finally, do we subnet? We subnet by transforming host bits into networking bits, thus creating additional networks from a single address block. Here is an example of subnetting. In this particular case, we have a base address of 192.168.1.0/24. In the first case here, if we borrow or if we transform one host bit into a network bit, we've created two new networks. In the second case here, if we borrow 4 bits, then we've created 4 new blocks. So in this one bit is 2 blocks. In this one, 2 bits is 4 new blocks. So as you can see here, in the case where we borrow 1 bit, we've actually transformed. Remember, this used to be a host bit, used to be a 0. We've transformed it into a network bit, therefore it becomes a 1. And our new subnet mask is 128, which is equivalent to a prefix length of 25. Over here, we've borrowed 2 host bits. Look at our host bits here. These used to be 0s. Look at it here. That's our base. Used to be 0s, and we've transformed them into 1s. Transformed them into network bits. And the net result, our new mask, is 192. And the prefix length is 26. So the little formula here, 2 to the b, where b represents the number of borrowed bits or transformed bits. So b is 1. So 2 exponent 1 is 2 new networks. So this formula here gives us the number of new blocks or new networks resulting from the transformation. And for each new network, we have 2 to the h minus 2, where h is the number of host bits. So here we have 2 to the 7 minus 2 is equal to 126. So we have 126 hosts per new network. Here, our formula. B, the number of borrowed bits, is 2. So 2 exponent 2 is 4. So we have 4 new networks. And in each network, we have 2 to the h. H is, how many host bits do we have left? 1, 2, 3, 4, 5, 6. 2 to the 6 is, 64 minus 2 equals 62. We have 62 hosts per network. So in this case right here, our first network will have a network ID .0/25, and our second network will have a network ID of 128/25. In the second case here, we have 4 new networks. The first network will have a .0/26. The second network ID .64/26. The third one is 128/26, and the fourth new network will have a network ID of 192/20. And in each of these new networks, we will have a maximum number of IPs equal to 62. Now let's review some of the formulas that we've just saw, formulas and variables. So in subnetting, you'll see H. H is number of host bits. B is the number of host bits that we've transformed into network bits. B is also the borrowed bits. I'm a little reluctant to using borrowed bits because borrowed implies that you will return. But once you've divided or subnetted a base address, it is very, very difficult to go back. And finally, N is the number of network bits. So taking these variables, you plug them into these formulas here. So number of new networks resulting from the subnetting. So if you've borrowed 3 bits, then 2 to the 3 is equals to 8 new networks. And let's say if you have 2 to the 6, for example, you have 6 host bits, then each network will be able to accommodate 62 hosts per new network. You need to remember these formulas as they will be used quite extensively in subnetting exercises. Well, let's just look at some very popular subnet masks. So we have the first one here that you've all seen. The second one, .128. The third one, 192, 224, 240, 248, and 252. So the smallest subnet masks yields 2 hosts per network. And yes, there are instances where you will only have 2 hosts per network. The specific case being a network connecting 2 routers. 2 routers simply need 2 routers that are connected to each other only need 2 IP addresses. 1 IP address per interface. Let's just look at a little diagram here to show that. So this is router 1, router 2, and let's say you're connected in a point-to-point or WAN connection. See, you only need 1 and 2 addresses. Why waste the rest when you can save? Alright, let us look at another practical case, except this time we will put in practice the formulas that we've used or we've seen earlier. So here we have a base address of 210.21.0/24. Some of the criterias, the largest network segment that is required, or the largest network segment requires a maximum of 25 IP addresses. And the subnetting criteria is such that the base address, you must subnet the base address to yield the maximum address utilization. Hence, we want to eliminate any waste of addresses. In this case, we will use the formula 2 exponent h minus 2 must be greater or equal to 25. So what is the smallest value of h that meets the criteria? So here, if h is equal 1, we don't meet the criteria. 0 is not greater to or equal to 25. H equals 2, doesn't meet the criteria either. H equals 3, no. H equals 4, nope. H equals 5, yes. If the number of host bits is 5, we meet the criteria. That is 30 is greater than or equal to 25. 6 also meets the criteria. 62 is greater than or equal to 25. However, if we use 6, we will not yield the maximum address utilization. So 6 is out of the question. Therefore, our h equals 5 yields the maximum address utilization. Alright, now that we have the number of host bits that meet our criteria, how many bits do we need to borrow? So the formula is 32 minus n, which is 24, plus h, which is the number of host bits. So 24 plus 5, 29, subtracted from 32 equals 3. So we have borrowed 3 bits. We have transformed 3 host bits into network bits. So we have basically broken our base address into 8 network blocks. And each network blocks can accommodate up to 30 hosts per address or per network. And the new mask is 255.255.224, prefix length of /27. Here is a practical real-life example. My ISP, my internet service provider, has subnetted a base address of 99.0.0.0/8 into a 255.255.254.0. So they have borrowed 15 bits, or they have transformed 15 host bits into network bits, therefore creating 32,768 new networks. And in each network is able to accommodate 2 exponent 9 minus 2, 510 hosts per network. So, in summary, to conclude, in order to extend the life of IPv4, several changes had to be implemented to the original addressing scheme, including subnetting. When the original subnetting scheme was put in place back in the early 80s, no one ever imagined that the internet would take off like it has taken off. Next, I will be preparing a Subnetting Basics Part 2, and we will be exploring more subnetting examples. In the meantime, if you want to practice, you can you can practice by there are many practice tests on Blackboard. All right, look forward to seeing you the next time. Have a nice